Welcome to part 2 of the boundary sensing section of this tutorial, where we are going to keep this cat from escaping from the box and maybe do even a little bit of level design as well. We'll see how far it goes. But let's continue on from where we left our last video. We just gotten the touching level, change x by -10 to cancel out the change x by 10, working here at these nested if statements. Nice thing about code is often it looks really complicated when it's all finished, but it is actually really just a repetition with slight changes to take into account sort of what needs to be done in each of these. So let's actually start by just grabbing a bunch of these blocks, putting the code in, and then we'll drop them into the appropriate places. So I'm going to grab 3 if-then statements, because we've already done 1 and we have 3 that need to still be done here. And we are going to create a sensing for touching. So if touching level, this is the same for all of them, right? Because they're all designed around if touching level. And we just need to then customize them to cancel out whatever the coordinate change is in each of these. So in this last one, we changed the x by 10 when pressing the right arrow and canceled it out to 0 if touching the level by changing the x by -10. Nice thing is that this one is actually literally the exact opposite. So if we're changing x by -10 when the left arrow is pressed to cancel that out to 0, we just need to add 10. So I'm going to drop this in there and click and drag, making sure it fits nicely nested inside right underneath the change x by -10 block. You can see how this starts to look complicated, but if you actually read it out to yourself, it's pretty simple. Now we're doing the up and down y-axis. And this is really the only change, so you got to make sure that you are using the change Y motion block as opposed to the change X. Otherwise you're going to get some weird sort of behaviors, like weird diagonal movements when you touch a level while moving up or down. Always make sure the axis being modified is the same for the if touching levels, and that the number is the same. I'm going to actually show you a few things about what happens if those numbers are different. So change y by 10. Just going to grab this and drop it into both of these. Up arrow, change y by 10 to make that 0. Change y by -10. And I'm going to drag and drop it right underneath there, nested nicely inside. Every once in a while, as you're doing Scratch, you might accidentally grab and like undo something or drop it in like that. You just got to make sure you kind of bring it out, separate it, drop it back in where it's supposed to do. Make sure the if key ones are your main stacked ones, and that these are set nested inside your other statements. Change x by -10, change y by -10, change y by 10, cancels out to 0, and we drop this right in there. Let's give this a little test. So can't get out this way, can't get out this way, can't get out that way, can't get out that way. Okay, so he's working in all directions. Notice this isn't quite perfect. There's like a little bit of a gap there, partially due to the size of this creature. So let's actually change him down, maybe even to a 30 size. And that really is quite a big gap there. That's one of the problems with Scratch, is it's not quite as clean as you would like it to be. So that is something I'm going to have to take into kind of account as I make my game. Yeah, that's really is quite a big gap. I guess it's about 10 units. So what happens if these numbers are not the same? So as you probably guessed, if I move this guy right in here, you're changing x by 10 or y by 10, whatever the number is, but you're changing it by 10 units. That actually determines the speed of which it's moving. So let's move this thing, change this to 5 and -5. We'll just do it for the x values right now. Often you have to click on the green flag just to kind of reset the code or refresh it. Notice the difference in speed now, right? He's moving a lot slower because he's only basically moving 5 units at a time. It slows him down. And notice this, I hit the side here, now I'm getting a bounce, right? So he hits the edge and then he's bouncing, and you actually can see that. That's because the bounce back now doesn't equal 0. Essentially this change combined with this actually equals basically a +5 or sorry, a -5 change. So he's actually going to bump back 5 units when he touches the edge. So you have to make sure that these are even if you want a hard stop. But if you do want to bounce, maybe something a little more subtle, you could go like -6 and +6 there. Reset this. Then you get a little bit of a less of a bounce. Boom, 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 boom. Kind of creates a nice little, just moves them off the edge a little bit there, and gives you a little bit of like an actual sort of feedback, which I kind of like, as opposed to just a hard stop. And just also moves you away just in case for some reason you do have a glitchy overlap. You can kind of bounce them off a little bit. So let's change that for the Y values as well. So -10, well, let's change this to 5, -5, and then in this case -6, in this case +6. So we're basically we're gonna move them back 1 unit. Let's update that. So a little bit of a bounce there, a little bounce there, a little bounce there, and a little bounce there. We now have boundary sensing working completely for our game. And that is literally the it for our directional movement. We've got our rotation style left, right, to have him pointing in the direction he's moving. We have our 4-directional movement. We have our 4-directional boundary sensing. This block here now represents the entirety of sort of our key input movement and boundary sensing. We're not going to really be adding anything else to this part. So that little bit of code is now done, and now we can move on to customizing our level design in the next video.